So right now, ladies and gentlemen, we have been working with this equilibrium constant expression, KEQ, which you need to start becoming familiar with. If you ever just see K, that is also the equilibrium constant expression. But we've been looking at this KEQ for equations and reactions that are at equilibrium. So if I look at the equilibrium constant expression for this reaction, it would look like this. Okay? And the issue with this is these concentrations right here are when we are at equilibrium. But we don't always start reactions when we are at equilibrium. As we saw yesterday, we can have initial concentrations. So here's the thing. What if we want to know what direction a reaction will shift to reach equilibrium? Okay? From the initial conditions. So let's say we have initial concentrations, and we want to know how that reaction will move to reach equilibrium from there. We have a way to do that. And the way that we do that is with something called a reaction quotient. Now, the symbol for reaction quotient is going to be the capital letter Q. And essentially what it does is this. It allows us to predict a direction that a reaction needs to go to reach equilibrium when we are given the initial concentrations. So now these are what are given, okay? And we can find out which way a reaction would need to shift, either left or right from that. And the thing with this equilibrium or this reaction quotient is it is the exact same formula as the equilibrium constant. You just plug everything in and you're going to get a value called the reaction quotient. And then what you'll do with that value is compare it to KEQ. So what we're going to do with this is we would compare Q to KEQ to see which way a reaction needs to shift. Okay, so it's the same exact math, you're just going to be working with some different numbers. So let's look at an example. If we deal with the production of ammonia, okay, in this case now notice we are given the equilibrium constant, so we're not asked to find it. But the difference is what we are given. We are actually given starting concentrations of the reactants and products. So ultimately what we want to know is which direction does the reaction need to shift from those starting concentrations to actually reach equilibrium. Okay, so we are going to need to write the formula for the production of ammonia, which you should be able to do. The N2 plus 3H2 yields 2 NH3. Okay, and what we're going to have to do is we're going to write the equilibrium constant expression, but it's going to be Q. Okay, but it's done the exact same way. It's still the concentration of the products, so NH3 squared all over the concentration of the reactants. Okay, so nothing's really changed. In fact, all you really need to know is that now these are initial concentrations. So if you are ever using initial concentrations, that becomes reaction quotient. But you plug them in and do the math just as we've been doing for the past couple of days. So the NH3 would be 2 squared all over N2 is 1 times 2 cubed. So simple math, 4 divided by 8 means that our reaction quotient is 0.5. So in this case, Q is 0.5. So then what we want to do is look at, okay, what direction does the reaction need to shift to reach the equilibrium constant? And one way that I do this is to actually just throw this on a number line. Okay, so 0.5 is over here, and KEQ is over here. So for this reaction to go from the initial concentrations, and that's what this is, these are initial concentrations, to get to equilibrium, which is what this is, it would have to shift this way, which means it would have to shift to the left, or whenever you shift left, you have to realize that also means you are shifting towards the products, or towards the reactants. So, in this particular case, because we had to go from 0.5 to 0.1, the reaction actually shifted more towards the reactants in the reaction. Okay? So that's how you work with the equilibrium constant. A few things. It basically is, if Q is greater than the equilibrium constant, then you're going to shift to the left, which you just saw. And if Q is less than the equilibrium constant, then you would shift to the right. But in any case, if you're not sure, make a number line. Okay? If Q comes out to be 0.75 and your KEQ is 10, okay, then you can easily see that, oh, I gotta shift to the right. Okay? So your assignment that I gave in class yesterday is what your homework is for today. That is due in class tomorrow. So you can complete this worksheet. If you forgot to bring it home, I've also attached it. And then you could also read your textbook, text pages 624 to 625 also covers this reaction quotient. So that is your assignment.